5C, simplifying fractions. Well, what do I mean by simplifying fractions? Well, I mean make them simpler, make them easier, right? Well, simplified, when we talk about fractions in either simplified form or reduced form, what we really mean is getting to the point where the numerator and the denominator have a greatest common factor of 1. Meaning that there's nothing that we can divide out of both the numerator and the denominator. So what if I have 8/10? Well, 8/10, so that's a proper fraction, right? 8 is smaller than 10. But we should be able to look at that right away and say, well, wait a second. 8 is an even number. 10 is an even number. Therefore, both of these numbers, the numerator and the denominator, are divisible by 2. So what I can do is I can actually divide both the top and the bottom by 2. 8 divided by 2 is 4. 10 divided by 2 is 5, and we end up with 4/5. And that is a fraction in simplest form. Let's try another one. What about 27/29? When I look at 27, I look at 29, and because of my vast experience, I realize right away that 29 is a prime number. Since 29 is a prime number, there is not going to be any common factor between these because 27 is smaller than 29, so 29 cannot be a factor of 27. So we have to leave it as 27/9. Well, what about 13/52? Well, 13/52, we can look at, well, I don't know, it's like 13. 13 is a prime number, 52 is not. I'm not seeing anything obvious here, but let's break this down a little bit and go, well, wait a second. Here's a possibility. If this is a prime number, we know we're not going to find any factor other than 1 and 13 here. So what if we just try dividing this into the 52? And it turns out that 13, well, so let's say 52 divided by 13 gives you 4. So 52 is a multiple of 13. So there is a common factor, it's 13. So if I divide the top by 13 and divide the bottom by 13, 13 divided by 13 is 1. 52 divided by 13 is 4, and I have 1/4. So 13/52 is equal to 1/4. And if any of you play cards, poker and such, this may stand out to you. 52 is the number of cards in a deck. 13 is the number of cards per suit. 2 through 10, Jack, Queen, King, Ace. 13 cards per suit, 4 suits, 13 times 4 is 52. So bringing it into something you may have seen before. So we can do that. Let's try another one. (36/80). So 36/80. Well, let's reduce it. Well, I look at this and I go, well, 36/80. Well, I see they're both even, so I can divide both the top and the bottom by 2. 36 divided by 2 is 18. 80 divided by 2 is 40. Well, they're still both even, so I see that I can divide by 2. 18 divided by 2 is 9. 40 divided by 2 is 20. And now I get into that 9 and 20. Well, 9 has factors of 1, 3, and 9. 20 has factors of 1, 2, 4, 5, 10, and 20. So nothing in common, we're left with 9/20ths. But if you look at what I really did here, I pulled out a prime number, I pulled out 2. And then I pulled out another prime number 2, I pulled out a prime number 2, I pulled out another prime number 2, right? And then I was left with a couple primes here, and I was left with, this could be 2 times 10, which is 2 times 5. So a method that we could use is prime factorization. You remember prime factorization? That's where we take the number and we just break it down into its prime components. 36 and we divide by 2 gives us 18. If we divide that by 2, we get 9. If we divide that, well, that's not divisible by 2, but it is divisible by 3, and that gives us 3, and we end up with 2 squared times 3 squared. Well, that's 36. What about 80? 80, well, if we divide it by 2, we get 40. If we divide that by 2, we get 20. If we divide that by 2, we get 10. If we divide that by 2, we get 5, giving us 2 to the 1, 2, 3, 4, 2 to the 4th times 5. So I've got my prime factorization. Now remember, we said that we could use prime factorization to find a greatest common factor. What we do is we look and say, well, what's the most of anything that we can pull out of here? I've got 2 2's here, I've got 4 2's here. Well, the most that I can pull out of both of them is 2 of them, because this one doesn't have any more to give. If you've got 2 apples and 2 oranges, and the other person has 4 apples and 1 banana, and said, okay, well, we have to give the same thing to someone. Well, this guy only has 2 apples that he can give. This guy has 4 apples, but for him to match it, he can only give 2. He's only got 2. I only have 2 2's here, I have 4 2's here. Well, the most that this one can give is 2, so that's my restriction. I have 2 3's here and none of them here. So he can't give any 3's, so I can't do that. I have 1 5 here, I don't have any here. He can give a 5, but he can't. So the only thing that they can give are those 2 2's. 2 times 2 is 4. Notice that 36 divided by 4 is 9. 80 divided by 4 is 20. So you can use prime factorization to simplify. And that's pretty cool. Does that mean that you have to use prime factorization to simplify? No. In fact, many times people will just start pulling things out and see what happens. (24/36). Well, 24/36, some of us may look at this and go, oh, I know what that is. Others of us, maybe not. So let's look at it. Well, what can I do? I can pull them out a piece at a time. I can say, well, they're both divisible by 2. 24 divided by 2 gives me 12. 36 divided by 2 gives me 18. I see I can pull out another 2. 12 divided by 2 is 6. 18 divided by 2 is 9. I go, okay, I can't pull out any other 2's, but I see they're both divisible by 3, so 6 divided by 3 is 2, 9 divided by 3 is 3, and I have 2/3. Okay? So I can do that. I can pull it out a piece at a time. Some of us may have noticed, wait, 24 is 2 dozen, 36 is 3 dozen, it's divisible by 12, giving us 2/3. There's nothing wrong if you did not recognize that. Okay? We can pull them out. Or, I can say 24 is 2 with 12, 2 with 6, 2 and 3, or 2 cubed times 3. 36 is 2 and 18, 2 and 9, 3 and 3, so 2 squared times 3 squared. And we look at this and go, I've got 3 2's, I've got 2 2's, I have 2 2's in common, I have 1 3, I have 2 3's, I only have 1 3 in common. 2 squared is 4 times 3 is 12. 24 divided by 12 is 2. 36 divided by 12 is 3. So options. One thing I love about mathematics is many times there are options. You can choose the method you want to use. Use the one that works the best for you, that gives you the correct answer most often. Don't try to be fancy just because there's a fancy method. Don't try to follow a certain form because the teacher said, this is the form that you have to use. If you have a valid method that works and gets you to the correct answer, by all means use it. And that valid method is not looking on a neighbor's paper or asking somebody else what the answer is or going on the internet for it. But if you know a method that allows you to get there, sometimes you may need to take a few more steps to get there than someone else. Fine, the key thing is you got there. Now, what if we want to do this with our calculator? Most calculators can simplify fractions for you. Let's say I have 20 25ths, and I want to simplify that. Now, I recognize I can do this on my own, but what about using a calculator? Well, obviously different types of calculators will do things in different ways. Right here, I've got a TI-30X2S, right? And I don't know if I can get it where you can see it well, but right about here, my finger's on top of it, is a button that says A, B over C. There's a button like that. If I press that button, I get a symbol that looks like that on my calculator screen. That symbol is acting as this fractional line. I know it's not pretty, it's not a fancy calculator for doing this, right? But that's basically acting as the fraction. So if I want to take 20 25ths and simplify it, I can plug that into the calculator by hitting 2, 0, the A, B over C button, which that's going to put 2, 0 on my calculator. The A, B over C button is going to put my little right angle thing there. And 25 to 5, that's going to 25. And then I hit the equals key. And my calculator, so I go, I'll try to put it where you can see it somewhat. So I go 2, 0. I hit my A, B over C button. It puts that little right angle thing there. 2, 5, and I hit equals or enters, and it gives me actually something that looks like a fraction. 4 slant line 5. 4 slant line 5. Telling me that this is 4 fifths. 20 25ths is 4 fifths. That was using a TI-30X2S. Now, I know you don't all use the same calculator, so let me pull up another type of calculator here. This one's just a little more colorful, right? So this is a Casio. So if I turn this on, in the Casio, I have this little button on the side here. It looks like, it's hard to get it where you can see it well there, but it looks kind of like a filled-in box with a line below it and then an open box. So it's got this filled-in box with a line below it and then an open box. That's my fractional button. If I press that button, this is actually going to give me a box with a line and a box on my screen, which is pretty cool. So I press that here, and now I have these two open boxes with a line between them. So I can put my fraction in. So I actually can press that button, and that will display a box over a box, and you'll actually see that there's a little cursor here next to this box on your display. And then if I put in 2, 0, it's going to put that 2, 0 in that upper box. In fact, it's going to replace that upper box with it. So now I have 2, 0 over a box. So I can say that changed my display to now look like this. And then I can either hit the right arrow, you've got this little center circle thing here. I can hit the right arrow or the down arrow, and you'll see that a cursor now went in front of this one. So I hit my, I hit that right arrow in my multi-key that says replay, right? If I hit that right arrow, it moves me down here. I can now type in the 25, and that's going to fill it in the bottom, which is going to replace my box there. And you can see that now I have 20 over 25. Trying to get it where you can see better. There you go. Okay, 20 over 25. And I hit my equal key. My equal key, and it tells me 4 over 5. 4/5. And there it is. So 4/5. So these calculators can actually reduce fractions for you. And that can be a wonderful thing. I have to admit the Casio calculators can be much easier with that. And to be perfectly honest, the Casio calculator has a tendency to reduce fractions instead of doing division, and you have to force it into division. So I gave you this fancy method of doing it. But different types of calculators also have this method of doing it depending on whether they have math print or not, which is just a fancy way of saying the calculator can actually decode and display an expression or an equation as you would write it, as opposed to just spread out with all these parentheses and divisions and additions and such. But what I can also do is I can just do 20 divided by 25. So 20 divided by 25, if I hit equals, it gives me 4/5. 20 divided by 25. So all I did was went 2, 0, divide 2, 5, equals, and it gave me 4/5. In fact, this is a common complaint that I have from students when they start using a Casio calculator. I can't give it to give me a decimal. It gives me a fraction. Well, luckily there is this button right here, the SD button, that if I press that, it turns it into a decimal, which we get a 0.8. So, ways that you can use your calculator for simplifying fractions.